everyone, I am Dr.B.Sivasankari, Assistant Professor of Physics in SFR College, Sivagasi. Today we are going to see an interesting topic of energy storage and distribution. First you should know what is energy storage and its distribution. Energy storage is the capture of energy produced at one time for use at a later time, to reduce imbalances between energy demand and energy production. A device that stores energy is generally called an accumulator or battery. Energy comes in multiple forms that only shown here. So if you see here means the energy is here comes in the right hand side figure. If you see means the energy comes from power plant, renewable sources, and it is stored as an energy storage device, and it is supplied by means of power grid to various houses and then to factories also. So I can say that energy comes in multiple forms, including radiation, chemical, gravitational potential, electric potential, electricity, elevated temperature, latent heat, and kinetic. Energy storage involves converting energy from forms that are difficult to store to more conveniently or economically storable forms. Some technologies provide short-term energy storage, while others can endure for much longer. Bulk energy storage is currently dominated by hydroelectric dams. So dams are also energy storage only, both conventional as well as pumped. Grid energy storage, that only I have shown here, is a collection of methods used for energy storage on a large scale within an electrical power grid. Common examples of energy storage are the rechargeable battery, which stores chemical energy readily convertible to electricity to operate a mobile phone. The hydroelectric dam, which stores energy in a reservoir as gravitational potential energy. And ice storage tanks, which store ice frozen by cheaper energy at night to meet peak daytime demand for cooling. Fossil organisms that later died became buried and over time were then converted into these fuels. Food, which is made by the same process as fossil fuels, is a form of energy stored in chemical form. So what the food we are taking is also it is an energy storage, and it is stored as a chemical form. So the left hand side figure also the same thing. The energy is stored in panels and grids, and by means of wind energy also we are collecting the energy and we are storing in panels, grids, and then we are supplying it to factories and then to houses, to electric vehicles also. So here if you see means one short conversion I have shown here. The sun's energy is converted into electrical energy by means of solar panels, and the energy is stored in batteries and that are supplied to the utility grids and to the houses. And then on the right hand side if you see means the electric vehicle, the green revolution, if you see means we are charging the electric vehicles by means of the stored energy. So it is a modern technology. Then energy storage systems. What are energy storage systems? Here I have mentioned only three things: batteries, thermal, and mechanical system. But actually if you see means there are so many types of energy storage. For example, fossil fuel storage, mechanical storage systems if you take means spring, compressed air energy storage, fireless locomotive, flywheel energy storage, solid mass gravitational, hydraulic accumulator, pumped storage hydroelectricity, thermal expansion. And then electrical and electromagnetic energy storage systems if you see means capacitor, supercapacitor, superconducting magnetic energy storage, that is the superconductor trains that is running in Japan. Then biological energy storage systems, it includes glycogen, starch. Then electrochemical battery energy storage system if you take means flow battery, rechargeable battery, ultra battery. Then thermal energy storage systems include brick storage heater, cryogenic energy storage, liquid air energy storage, liquid nitrogen engine, eutectic system, ice storage air conditioning, molten salt storage, phase change material, seasonal thermal energy storage, solar pond, steam accumulator, thermal energy storage. Then chemical energy storage systems, if you see, means biofuels, hydrated salts, hydrogen peroxide, power to gas, methane, hydrogen storage, oxyhydrogen. So these are some of the energy storage systems. So if you take, means there are infinite storage systems available both in nature as well as in artificially. So now we can see as an overview, what are these energy storage systems? India has set a target to achieve 50% cumulative installed capacity from non-fossil fuel based energy resources by 2030 and has pledged to reduce the emission intensity of its GDP by 45% by 2030 based on 2005 levels. The incorporation of a significant amount of variable and intermittent renewable energy into the energy mix presents a challenge for maintaining grid stability and uninterrupted power supply. The challenge with renewable energy sources arises due to their varying nature with time, climate, season or geographic location. Energy storage systems, we can say it as ESS, can be used for storing available energy from renewable energy and further can be used during peak hours of the day. The various benefits of energy storage are help in bringing down the variability of generation in RE sources, improving grid stability, enabling energy peak shifting, providing ancillary support services, enabling larger renewable energy integration, brings down peak deficit and peak tariffs, reduction of carbon emissions, deferral of transmission and distribution of capex, energy arbitrage, etc. Energy distribution. So the stored energy are distributed. So we should know what is energy distribution. Now most of us know that flipping a light switch turns electricity on and off, and that when home lost power, we can't watch the TV or use appliances that run on electricity, isn't it? But where does the electricity come from? You should know. And how does it get to homes, schools and businesses? That you should know. The answer is here. The energy distribution refers to how electricity is delivered to all the places that use it. This process occurs thanks to power lines, substations and transformers. So you have to thank the power lines, substations and transformers. Electricity starts at a power station where the voltage is high and ultimately gets delivered to homes and businesses at a range of voltages depending on how it is used. So that only I have shown here how it is distributed by means of grids. Then on the side, if you see, means there is another picture showing showing how India is using to how much extent the various resources as energy storage devices and how it is distributed. So that percentage as a chart I have shown on the right hand side. So this is a overall view of how energy is stored and what are the sources of energy and what are the types of energy and how it is distributed. So as I already said, distributed energy storage refers to the store of electrical, thermal or cold energy for peak demand, which stores surplus energy at off-peak hours and then dispatches the energy during peak hours. So what are the sources of energy here? The main three sources I have shown here is hydro, then wind, then solar. But actually the three energy storage systems which are artificial, I can say, is batteries, thermal or mechanical systems. Then from naturally how it can be utilized in for a natural way, means as a nuclear power and as a natural gas. Then some of the types of energy I have already said: pumped hydroelectric, compressed air, flywheels, batteries, thermal energy storage. Then the types of storage also I have shown here. The world of data storage, storage devices are divided into one of the two categories based on how frequently an organization needs to access the data: primary storage and secondary storage. The main difference between storage and distribution functions that you have to know. Warehouses store products for longer period of time. So the which store products for longer period of time in warehouses. On the other hand, distribution centers have a faster flow rate through storage to the store or customer. This means that products sit in store for less time. The storage function measures the amount of energy that is stored inside the system at any instant of time. It is reasonable to expect that the value of the storage function at a particular time instant depends only on the past of the time trajectories through the memory of the system. So, the energy storage, after storing energy, you have to show some response of transforming that storage, and what is the energy storage system efficiency that you have to took into consider, and then the energy efficiency. What is the energy efficiency? What is the expected percentage of efficiency you can get it from the energy storage? That and all you have to consider. So these are the main things you have to consider and use it the energy storage for distribution. So energy storage and distribution, it is used in a green way in 2025. It is a remarkable achievement of our India. Thank you.